Okay. Now let's look at this question. This question came in GATE 2016. The question is, let an be the number of n-bit strings that do not contain two consecutive ones. Okay, which one of the following is the recurrence relation for an? Okay, so it turns out that they are asking for do not. It turns out that if we have to find the number for which there are two consecutive uh, ones in that bit string, that recurrence relation is pretty easy to find. So firstly we will find that thing, and then from that we will find an. So let's that recurrence relation will be let's that be bn, and this one is an. So my point is that for all n bit strings, either it is having two consecutive bit strings, two consecutive ones, or it is not. So okay, so when we are talking about an plus bn, then bn is the number of n bit strings which are having two consecutive ones, and an is the total number of n bit strings which do not have two consecutive ones, right? And overall, what will be the summation? Their summation will be all the number of n bit strings, that is 2 to the n, right? N bit strings are there, every bit can be either 0 or 1. So basically this equation holds. We will come back to this equation later. In the meantime, we will firstly try to simply compute bn. Once we compute bn, then from that we can find an, and then we'll choose the options. So firstly let's get into the calculation of bn. Okay, so bn is what? We have to find all the n bit strings which are having two consecutive ones. So how we can do that? So n bit strings is there. Let's say this one is the last one, and this one is n minus 1 bits are there, right? And this one is the last bit. Now here there can be two possibilities. It can be either 0 or it can be 1. If it is 0, then what is going to happen is that it doesn't matter what is this side, this thing is not contributing to two consecutive ones. So if the earlier earlier n minus 1 bits have two consecutive ones, then it is going to have that particular count, otherwise it is not going to happen. So my point is simply that this is not contributing. So if the n minus 1 bits are so my point is simply that whatever is the number of n minus 1 bit strings which are having two consecutive ones, simply append 0 and we will get that. So appending 0 is not going to change that two consecutive ones, and that's why the number of the whether that particular string has two consecutive ones or not, that is not going to change. However, if I am having 1, then there becomes two conditions. And what are those two conditions? The two conditions are something like that: the last is 1, that is fixed, but now the second last can be two things. It can be 0 or it can be 1, and rest how much? These are n minus 2 bits are there. I'm talking about the second last one. This last one is fixed, right? This last one is fixed. I'm talking about the second last one. I'm talking about the second last one. Second last one can be 0 or 1. What happens if it is 0? See, the last one is 0 and the second last one is again 0. So we can safely say that with the n minus 2 bits, whatever is the number, we are simply appending 0 0. So it is not going to change anything. So that's why if it is 0, then we will get the count from the n minus 2 strings. However, this is interesting case that here if it is 1, then see that we already have 1 here, and again we are having 1 here. So the condition that a particular n bit strings is going to have two consecutive ones is satisfied here only. So 1 is already there. After that, I don't care that in n minus 2 what is the situation, whether they are consecutive ones or not, I don't care. Whatever gibberish is here one is there, so that thing is going to satisfy, that is going to be in my count. So all these n minus 1 bits, they can be 0 or 1 0 or 1 0 and two ways. So basically 2 raised to the power n minus 2, in any fashion you fill all these two, I don't care. All this 1 is fixed, then this is going to be my count, right? Always will be there, right? So basically bn entire n bit strings in terms of the recursive, we can write it as the bn minus 1 plus bn minus 2 plus 2 raised to the power n minus 2. So this thing is the expression which we have got, bn. Now we have to compute an. So basically an is what? An is equal to 2 to the n minus bn. And what is bn? We'll write it down, sir. So it will be so it will not be that much simple. Why? Because we have to substitute all the values of this thing bn to n. So basically firstly let me write it down. It will be 2 raised to the power n minus bn, and bn is basically bn minus 1 plus bn minus 2 plus 2 raised to the power n minus 2. Okay, so basically this thing is going to be 2 to the n minus, this thing is going to be b n in terms of an. How I can express? So I can write similarly an minus 1 plus bn minus 1. Okay, I can write it how? I can write it like 2 raised to the power n minus 1. Similarly I can write a n minus 1 n minus 2 plus b n minus 2. I can write it 2 raised to the power n minus 2, right? In that fashion I can write. So my point is that this thing bn, I can write it bn minus 1, this thing I can write it as 2 raised to the power n minus 1 minus a n minus 1. Okay, that is my point. Minus bn minus 2. See, this bn minus 2 thing, this thing can be written as 2 raised to the power n minus 2 minus a n minus 2. Got it? And then minus 2 raised to the power n minus 2. Okay, so let's simply expand it. So 2 raised to the power n minus 2 raised to the power n minus 1 plus a n minus 1 minus 2 raised to the power n minus 2. Okay, so this so basically is 2 raised to the power n minus 2 minus plus a n minus 2 minus 2 raised to the power n minus 2. Okay, so you can understand it that it is going to be something like this, that 2 raised to the power n, this thing and this thing, so it will be added, so minus, and then it will be 2 times 2 raised to the power n minus 2, and which will be minus 2 raised to the power n minus 1. Now this will be minus 2 raised to the power n minus 1, and this will be minus 2 raised to the power n minus 1, right? So these two things will be again minus thing will come out to be common, and it will be 2 times 2 raised to the power n minus 1. Okay, and when it is 2 into 2 raised to the power n minus 1, so it is minus 2 raised to the power n. So this will be minus 2 raised to the power n, and this will be 2 raised to the power 1, so it will cancel. So basically my point is that this entire, all these things will come out to be cancelled. Final expression will be an is equal to an minus 1 plus an minus 2, right? So this thing is going to be remaining an is equal to n minus 1 plus n minus 2, and that is the final recurrence relation we have got. So an is equal to n minus 1 plus n minus 2, b is the correct answer.